Find the area of the region enclosed by the inner loop of r equals 2 minus 3 sine theta. So I already put the tables in and the polar grid, and I made the interval for every pi twelfths. So I just kind of filled that in. Now all I'm going to do now is fill in the rest of the table for r. Oops. I forgot one of my values. Okay, so there we go. So now what I'm going to do is I'm going to take each of those points and I'm just going to graph them. And this is what I want you to pay close attention to. So now 0, 2, so there's that one. And I'm just going to continue. And I want you just to watch the way this thing graphs. And what you notice, I'm back to 0, 2 again. So, and that's what I wanted you to see here, is if you take a look at this graph, now we can see the mapping here very clearly. So if I start here, I just take this around, I loop it around, I come back around, and then I come back. Okay, so what we have to find is we have to find the region enclosed by this inner loop in here. So that's what we got to find. So now we realize that we passed right over it. Because keep in mind here that if I'm going to see where this inner loop starts and ends, it's going to be there. And that would be at 0, 0. But if you look at all of our points, we don't have any 0, 0s there. So we never really hit the point where our interval starts and where our interval ends at there. So what we'll have to do, since we didn't run into that with the values we picked, is we're going to have to just solve this equation here. So that means I'll take the 0 equals 2 minus 3 sine theta here. And remember, I plugged in 0 for r because that's what we're looking for here. My r has to be 0. So then I'm going to move the 2 over and divide by 3. So really, I have the sine of theta equals, because when I move the 2 over, it's going to be negative. And then I'm going to divide by negative, so it's going to be 2/3. So what I'm looking for is theta equaling sine inverse of 2/3. And that's going to put me in the first quadrant, which is perfect because that's where I hit 0 first. And I'll kind of show you how that works. Notice here, I went from 0.5 to negative 0.121. And if I look at the 0.5 there, pi 6, that's going to be here. And then the 121 is going to be there. So I pass right over it. So that happens in here somewhere. Okay, which would be in the first quadrant. It'll be one of these angles up here where that would happen at. Okay, so that's how I know I'm in the first quadrant. So I know that this is going to be a positive angle, and that positive angle will be where I start. And also keep in mind here, I'm dealing with radians. So that means my angle measure is going to be in radians here. So if you get a different number, like 60 or so degrees or whatnot, that means you probably have yours in degrees. So this is going to be 0.72972 blah, blah, blah. I just wanted to put that in there so you can see exactly what the number is going to be that you should get on your calculator. So now I see that's where I'm going to start. Now then, where I'm going to end is another question. So now I have to find that. So I found the angle somewhat over here, where that would be. Now I have to find the angle over here where that would be. Now that's easy enough to see here, because if I know that this angle over here is, let's say that it happens there, so then that'll be about 0.72 radians there. And if I look at this angle here, that's what that angle will be. So then I'll have to think about it on the other side in the same place, which would be about there. And this angle is also going to be that 0.729. So if I want to think about the angle here, that angle would be 180, or pi minus that 0.72. And pi is 3.14, blah, blah, blah. So it would really be that 3.14 minus this 0.729 number, which is approximately 2.411864, blah, blah, blah. Okay, so that's what it's about there. So that's where I'm coming out of that circle, or loop, I should say. So at this value here, I'm entering it. And at this value here, I'm coming out of it. So those are going to be my bounds. Now again, I want to be very specific with my bounds here, so that I can be exact. I don't want to use these decimal approximations, but I kind of gave those to you so you can kind of get your hands on what we're dealing with here. Instead of writing sine inverses, that looks a little intimidating on a grid like this. So now we're just going to set up those integrals. So now if I'm going to do my integral is going to go from sine inverse of 2/3 to pi minus sine inverse of 2/3. And then my function is going to be the 1/2, right? Okay, and then I need my f theta squared. So that's going to be my 2 minus 3 sine theta, that's my f theta, squared d theta. And this approximates to 0.44088. So there's the answer for this one here.